Alright everybody, for this video we're going to talk about polynomials and do some sketching. Let's get into it. Busy, gotta go! For each polynomial function below we're going to do several things. Let's just do it. So first we've got a polynomial in factored form. What is the degree? Well, we can take the individual degrees of the factors 1 and 2 and add them. So degree 3. What are the zeros? The zeros are the x values where the whole function is going to have an output of 0. So we got x equals 0. We can just state the multiplicity right now. That's going to be multiplicity 1 because the exponent is 1. And the other 0 is x equals 3. This one, however, has multiplicity 2 because of that little exponent there. So what does that tell us about whether the graph crosses the x-axis at each x-intercept? Well, that tells us we're going to have an x-intercept at 0, 0. And since the degree is odd, the degree is 1, the graph will cross at 0, 0. However, at the x-intercept that corresponds to this one, that'd be 3, 0, the graph does not cross, because if there's a multiplicity of an even number, graph will not cross, it will only kiss. Okay, let's sketch this graph. So what we're going to have here, quick sketch, y-axis, x-axis. Let's put the zeros. So we've got a 0 at literally x equals 0 and a 0 at x equals 3. Okay, now we're going to build from there. Building from there is based on the end behavior. So let's take a look and notice that the leading coefficient is 1. So we've got an odd degree positive lead coefficient. So after this 0, it's going to tend, the function is going to go to infinity because odd degree positive lead coefficient looks like this. So we're going to go up here. Then we said the graph does not cross here. That means it just kisses and goes back up without crossing. And then it's going to cross at 0, 0. So it's going to look something like this because the end behavior here is going down. All right, function 2. So here we've got another factored polynomial. Same concept. Exponent of 3, exponent of 1. So the overall degree here is going to be 4. Okay, let's go to the zeros next. Zeros are the zeros of each factor. So we're going to have a 0 at 0. And this time the multiplicity is 3 because the exponent is 3. Here we've got a 0 of 2, multiplicity 1. So, let's see, what's the graph going to do? Multiplicity 3 is odd. So the graph will cross at the x-intercept of 0, 0. And because this is also odd, the graph will cross at 2, 0. So when we draw our sketch, I'm going to zoom it out a bit here for extra detail. So we've got a 0 or x-intercept at 0, 0. Let's do x equals 2 as here's 1, here's 2. Okay, just for a little bit of a clarity. 0, okay, -2. Okay, so start with the ends. I like to start on the right. Start with the ends. We need to look at the end behavior. What's the end behavior of an even degree lead coefficient of -1? It's going to look like a downward parabola. So that means that to the right of this 0, it's going to go down and to the right, going to negative infinity. it's going to cross the x-axis at 2, 0. So it goes up, and it's going to cross back down at 0. But since there's this multiplicity 3, it's not going to go straight through. It's probably going to have a little funkiness like this. And then, because of the end behavior, it's going to go back down. Something like that. And so, there you have it. Even degree polynomial, negative leading coefficient, with accurate zeros of x equals 0 and x equals 2 shown. Shall I go back and explain? Sure, why not? Right quick. So, remember, zeros are x values where the whole function equals 0. That's the definition of a 0. By the way, other books or sources will call these roots. So this function has a root at x equals 0, means the graph has an x-intercept there. Has a root of 0 at x equals 3, so the graph has an x-intercept there. But x-intercept just means it touches the x-axis. The y value is 0. It doesn't cross if the multiplicity is even. So here multiplicity 2, that's even, is the only time in these two examples where the graph simply touched without crossing the x-axis. We'll build on this in future videos, shall we? For now, I'll say, let's just take a look at this beautiful acrylics, look at this beautiful color. Let's say keep asking questions, and let's say, as always, go blue.